Good morning, all. I am continuing with the IUPAC nomenclature of organic compounds. The first part I have already done. Those who have not watched it, please watch it, write down the notes, and come back. Three rules I have already taught, and this is the fourth rule what I am going to teach you here. So, the fourth rule. When two substituents are having equivalent positions, which should be taken as the important one? That is the fourth rule. So if two substitutions are found to have the equivalent position, the lower number is given to the one coming first in the alphabetic order. For example, if I am writing this compound CH3, CH2, CH, CH2, CH3. That is, in this carbon, one ethyl branch is there. Then CH2, CH2, CH. In this carbon, one methyl group is there. Then CH2, CH3. So if I am counting from left to right, then 1, 2, 3, 4, 5, 6, 7, 8. And if I'm counting from right to left, then 1, 2, 3, 4, 5, 6, 7, 8. So you can see that in the third carbon, there is a branch, that is ethyl branch, ethyl. When I count from left to right. And the sixth carbon, there is a branch, that is methyl branch. Now, if I'm counting from right to left, methyl branch is coming on the third carbon and ethyl branch is coming on the sixth carbon. So actually it is equivalent position. So how can we decide which is important? We have to see the alphabetic order, E or M. E is coming first in the alphabetic order. So E will be given the small number, that is number 3. That means in this particular compound, you are supposed to count from left to right. So what will be the name of this? 3-ethyl. 3, E should be capital, ethyl. Then put a hyphen, then 6, isn't it? 6-methyl. 6-methyl, and total number of carbon atoms are 8. So it is octane. This is the name of this particular compound. So we have seen 4 rules for writing the names of the compound having branches. Now, suppose the branches are coming with other branches. That is, in a branch, if extra branches are there, then how will you name it in IUPAC system as well as in common system? Let us see that. Example, CH3. This is rule number 6. CH3, CH, CH2, CH. Then CH3, one branch here, CH3, one branch here. And this carbon is attached to the main organic compound. So all together, this is a branch. Don't forget that this is a branch which is attached to a main compound. That compound I'm not writing because I'm going to teach you if branches are there in the branches. These two are branches in a branch. Clear. So how can you name it? So the carbon which is attached to the main compound, that is this carbon, this is given as number 1. This is 2, this is 3, this is 4. And first and third carbon, we have 2 branches. Both the branches are methyl branches because only one carbon is there in this branch. So how can you name this? 1, 3. 1, 3. 2 methyl groups are there. So dimethyl. Then total number is 4. 4 carbons are there in the main branch. So you can write it as butyl. I will not write it as butane. Why? Because this is a branch. Branches are always ending with YL. So this is the name of the branch. 1,3-dimethyl butyl. Now, this is the way IUPAC system, and some names in the common systems are also allowed by IUPAC. So what are these names we will see? You have to study this And it is very important. It is easy to name if you know this branch names. For example, CH3. Example, this is three carbons are there. The name of this is, and second carbon. See, three carbons and the second carbon is attached to the main compound. So the name is isopropyl. Three carbon, that is why propyl. Second carbon is attached to the main compound, that is why iso. So isopropyl. Now next is CH3, CH2, CH, CH3, and see, this carbon is attached to the main compound, and this is totally four carbons are there. And in this carbon, one branch is there, isn't it? CH3 branch is there. This CH3 branch is attached to a carbon which is secondary. So the name of this is secondary butyl. Actually, when I say common name, you cannot say particular rule and all. I'm just making you understand. That's all. We cannot see particular rules in common names. So this is secondary butyl. Now next is CH3, CH, CH2, and in the second carbon, one branch, and this is attached to the main compound. Always when second carbon branch is there, it is known as, this is CH3. Branch is there, it is known as iso, and totally four carbons are there. So this is isobutyl. This is known as isobutyl. Clear? Now you will study two more. That is, next one is CH3, 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 a branch. Okay, and this is totally four carbons are there, and this carbon is tertiary. So it is known as tertiary butyl. This branch is known as tertiary butyl. Now we will study one pentyl branch also. Pentyl means surely five carbons will be there. We know that the name of this compound is neopentane, and I'm making it as a branch by removing the 3 and adding 2, so that there will be a bond here which is attached to the main compound, and its name is neopentyl. So these are the common names of some branches. You should study this, write and practice and study. Now, next is cyclic compounds. How can we name cyclic compounds? Let us see. If it is pentane, suppose we have to show the IUPAC naming of pentane. So we can just draw this, a pentagon, and we should know that it is cyclopentane. And if you show a hexagon, it is cyclohexane. That is, it is according to the mathematical geometry we will name. For example, a square. This is cyclobutane. These are cyclic compounds without branches. Now, we will see with branches how we will name. That is very important. For example, a compound with branches. This is one branch and this is another branch. Okay, now this is a bond line formula. This type of formula is known as bond line formula. We can expand it. I will expand it and show. This is the same and the branch will be, this is one line, means it is CH3. And this I am going to show, this is CH2, CH2, CH3. Okay, so you can see that this is methyl. This is methyl branch and this is propyl branch because three carbons are there. So it is propyl branch. Now, how can you count this? We will see the alphabetic order, whether which is coming in alphabetic order, M or P, which is coming first. We know M is coming first, right? So that this will be given number 1, 2, 3, 4, 5, 6. The same thing here. These are both the same compounds. 3, 4, 5, 6. Now what is the name? Number 1 carbon methyl group. So we can write 1 methyl, 1 methyl. Now on the third carbon propyl group, 3 propyl. And because it's a hexagon, it is cyclohexane. Cyclohexane. So this is the name of this particular compound. So this is one rule. According to the alphabetic order, we can give number to the branches. Now, one more rule you have to study. That is, if two branches are coming, more than one branches are coming in one carbon. For example, in this, two branches are there. This particular carbon, two branches are there, and this particular carbon, one branch is there. And now I will expand this and write, this is 2 methyl group, and this is one ethyl group. Now we will see what is the rule. If more than one branch is there in one carbon atom like this, you don't have to think about anything. You can give number 1 to it. So more branches are there, that will be carbon number 1. This is 2, this is 3. 1, 2, 3. So how can you name this? There are 1 dimethyl. Now, you know that this is methyl and this is 2 carbon branch. So it is ethyl. So what is the name? See, even though ethyl, for ethyl, 3, number 3 is given, E is coming first in the alphabetic order. So you have to write ethyl first with 3 as the number. So 3 ethyl. You will write 3 ethyl. Then 1 dimethyl. Dimethyl. Then because it is a hexagon, cyclohexane. Cyclohexane. So this is the way cyclic compounds are named. So today I told you one more rule for branched hydrocarbons and the rules for naming the cyclic compound, how to number and all. Now one more important thing you have to study, that is functional group. When more than one functional group is present in a compound, how can we name it? That will be taken in the next class. Thank you, children.